Hello dear students, welcome back. This is Dr.Jyoti Shegokar and you are welcome in my channel Chemistry in Engineering, where we generally study the different topics which comes under the heading of engineering chemistry. So guys, without wasting a time, today we'll start our topic. It is nothing but analysis of coal. Coal, it is a well-known term because it is used from a very long time as a conventional type of energy, as a non-renewable type of energy. For getting that energy, a fuel is used, which is a coal. So there are different purposes where the coal is used, like for industrial purposes, for railway engines, we know, for the domestic purposes, different ways are there to use the coal. So it must be the thing that we must study the analysis or to study the composition of coal. Analysis of coal means we have to analyze it. We have to know what are the different components are there, in what percentage. This thing is important. Otherwise, when we see coal from mine to mine, all type of coals are the coals. So they are having the same type of components or constituents present in it. Like carbon, it is present there always. Then hydrogen, it must be there. Nitrogen, oxygen, sulfur, ash, all the things are there undoubtedly. But what is its composition? All the coals having the same composition of carbon? No. Because of this particular point, we have to analyze the coal to know the composition according to its use again. Means wherever we want to use it. For example, we want a very good quality coal, so it must have a highest content of carbon. It must have a lowest content of ash. It must have a lowest content of moisture. So according to that, the use of coal is there. So there are three important points for which we have to carry out analysis of coal, like price fixation, like its industrial utilization, like its commercial classification. So for getting all the three main things, the analysis of coal is needed. So analysis of coal is done by two different ways: by proximate analysis, that I already wrote here, and second is by ultimate analysis. In proximate analysis, in a groups, the contents are determined. Like the contents are determined as a moisture determination, as a volatile matter determination, as a ash content determination, and as a fixed carbon determination. So here in a groups, generally all the points are there. Moisture means all the type of water or H2 which is present in it. Volatile matter, all the types of gases are determined. In ash content, particular those remain residue, it is determined. Then in fixed carbon, only the fixed carbon will be determined. So in this way, when the grouped all the things are determined, it comes under proximate analysis. While it's another type, that is an ultimate analysis. In ultimate analysis, each and every component is determined differently, individually. That is ultimate analysis, like determination of carbon, hydrogen, sulfur, nitrogen, oxygen. Individually, they are to be determined. That is called as an ultimate analysis. So today we will discuss about proximate analysis of coal, which is a very important for the knowing the quality of coal according to its utilization. So guys, with this myself once again welcome you all. I am Dr. Jyoti Shegokar, and we will start our topic with a very high speed here. Okay. Now, proximate analysis. At first, we have to determine moisture. So, for this purpose, we will need to carry out the procedure. So, for the procedure, we know that require number of apparatus, number of chemicals. So, like that, here we are going to use one important apparatus. It is called as a silica crucible. So, the silica crucible must be used here, and it is choose to use because it is having a very high melting point as it is made by silica. So whenever we will feed it to the very high temperature, it will not react itself. So the all procedure or all the process with the coal, it will carried out very safely or with a very high temperature also sometimes. So here we will choose one silica crucible with this lid. In this silica crucible, the sample of coal will be taken. So just take 1 gram of coal sample, because we know that only a sample of coal, not a total amount of coal, sorry. So this 1 gram of sample of coal has been taken in this silica crucible, and it is proceed further that before that the weight of silica crucible will be taken properly. Weight of coal will be must required according to the getting a very proper results. So the weight of 1 gram of coal sample has been weighed, and it is just taken in a silica crucible which is made by totally silica. Now this lid which is you can see here that it is to be removed during first time. So without lid, this silica crucible is to be put into oven. So oven is a particular machine where there is a temperature is given in a proper what type of temperature is required, or how much temperature is required. According to that, the silica crucible is put into the oven, and the temperature range will be selected. So for determining particularly moisture, that how much moisture is present in that coal sample, so for that here temperature is set up to 106 to 110 degrees Celsius. That temperature should be set on the oven or in the maffle furnace. These are all the, just I am telling you that oven or maffle furnace, these are the things which are there in the lab. These are the different type of devices which are used for the purpose of carrying out the proximate analysis. Because of a very high temperature range, either with a very constant speed or at a particular specific time, these things are required. So silica crucible is put into the oven for about temperature range of 106 to 110 degrees Celsius, and it is for about 1 hour. For 1 hour, the silica crucible is to be put into a oven. Then after 1 hour, just remove that silica crucible. Then when it is removed directly, it must be at a very high temperature. So first cool it up to room temperature, then it is to be put into the desiccator. Desiccator is one of the container in which some calcium chloride is present, and the water vapors which are produced by the sample of coal or which are remain there, if so they are to be absorbed by calcium chloride. So for that, such a sealed container which is made by generally glass is there, which is called as a desiccator. So to get removed all the type of moisture content, the silica crucible is to be put into the desiccator. Then after removing from desiccator, we have to take the weight of silica crucible, that is ultimately weight of the coal sample. By removing the weight of exact only silica crucible, we will get the weight which is remained of that coal sample. So in this way, we will get here a difference in the weight of the coal sample which was taken at first, that is 1 gram, and weight of the coal sample which is after process of burning, that is after removing the moisture. So here we will get the difference. So we can calculate here percentage of moisture is equals to loss in weight, that is the weight of silica crucible, weight of the coal sample, weight of the coal sample which was taken at first minus weight of the coal sample which is after the procedure. So that is called as a loss of the weight of coal. So loss in weight of coal into 100, because we want to calculate here percentage. So percentage of moisture is equals to loss in weight into 100 upon total weight of coal sample, that is just 1 gram. So in this way we can calculate percentage of moisture. So moisture which is present in the coal sample, it is not required for the good quality coal. So lower the moisture content, higher will be the quality of coal. So because of for the purpose of transportation, where we need that coal sample, it will require a very high energy or wealth. So for avoiding these things, if the coal sample is having a low amount of moisture, it will be better for the quality of coal as well as for the health of human being also. Okay, now after that we have to calculate the volatile matter. Now this procedure is continuous. We want to calculate volatile matter, it must be calculated after the removal of moisture. So this is the very in a proper sequence. So to calculate a volatile matter, just moving further, that the silica crucible from which just the moisture has been removed, that silica crucible it is to be used. So percentage of volatile matter, the silica crucible here now which is remained, and here it was totally free from the that particular lead. So that lead is to be put during the calculation of volatile matter. So here we have to put that lead, so that the volatile matter, that the gases which are produced, that will just removed once. Okay, so here this silica crucible we have removed, just we have taken afterwards, after the removal of moisture and calculation, it is put into the oven or Maffel furnace. Here we have to change the temperature range, that is 925 plus minus 25. So means 900 to 950 the temperature range can be set. So this temperature range is there, and here time it is very specific, that is 7 minutes. Only for 7 minutes it is to be put into the oven or Maffel furnace, so that all the type of volatile matters should be removed. Now what is this volatile matter is? Volatile matter, this word itself indicates that at the room temperature, all the gases which are present in the coal sample, which are also not required for the good quality coal, for the getting good calorific value, it is not required. So that is called as a volatile matter. All the type of gases, it includes the carbon dioxide, carbon monoxide, hydrogen, nitrogen, sulfur, oxides of nitrogen, oxides of sulfur. It is because there are two different types of gases, like combustible and non-combustible. Whether the gases are combustible or non-combustible, they are not required for increasing any calorific value or for the proper ignition temperature. They are not required. So that's why lesser the amount of volatile matter, good will be the quality of coal. So here after 7 minutes, the silica crucible, after 7 minutes putting into the oven, it is to be removed. Again carry out the same procedure like we had carried out during the determination of moisture. Just it is cooled up to room temperature. Then it is after cooling up to room temperature, just take its weight and consider the next calculation, that is percentage of volatile matter equals to loss in weight. Now here loss in weight means what? Loss in weight is equal to weight of moisture free coal minus weight of coal after the process of this particular volatile matter removal, that is the loss in weight, into 100 upon total weight of coal sample. In this way we can calculate percentage of volatile matter. Okay, now moving further, this material or that particular substance of the coal which is moving further, same substance will be there. So for the content calculation of ash content, simply take again that same silica crucible. Now here during third time again there is no requirement of any lid. So it is to be fed to the oven just for for half an hour, and here temperature is 750 plus minus 50 degrees Celsius, means up to from 700 to 800 this temperature will be required for the burning process, and time it is just half an hour, 30 minutes there must be the put it into the oven. So after half an hour remove the silica crucible and take again its weight. Now during this time we have to check whether there is some remain in the coal sample, because the burning things should not be there. The required things which are combustible, that must not be there, because the ash is nothing but the last residue which is totally unburnt. It is not helpful for any burning process or any getting calorific value. So this silica crucible, after putting into oven for half an hour for such a temperature, it is removed. It may be very red hot. So firstly it is to be cooled at a room temperature and then take its weight. After taking its weight, we can get percentage of ash which is equal to weight of the residue. That is, here we don't have to take any loss in weight, but the weight of coal which is remain, weight of that sample of coal which is there after burning process, after total burning process. So that is called as the weight of the residue into 100 upon total weight of coal sample, which is a quantity of coal in percentages, quantity of ash in percentages. So in this way we can calculate ash. Ash is also one of the unburnt portion which will not burn any time, so it will remain there after the burning process. So this ash is also not required for the good quality coal, because the solid ash, when on the grate the large amount of coal is burned, so that ash, when it is at a very high temperature, it may be looking like a liquid type of large particles, and they can fix up into the grates where the that different type of nets provided for the burning process. And for the burning process, due to this presence of solid residue, there may be some we can say that obstacles will be created. So it will be very hindrance showing process. So there must not be ash. But ash is we can say that unavoidable thing. So the low amount of ash will be required for the good quality coal. Those coal which is having a very low amount of ash is a good quality. So in this way, this is particular significance of ash. Now last, moving towards the percentage of fixed carbon. So we don't have anything to calculate the, means a solid thing in the procedure to calculate the ash. So it can be calculated by just the calculation that percentage of fixed carbon is equals to 100. As because these all are the percentages, we can consider all the percentages of the ash, volatile matter and moisture. So 100 minus percentage of moisture plus percentage of volatile matter plus percentage of ash, means by subtracting all this type of things from the 100, we can get here the percentage of fixed carbon. Now fixed carbon is a very precious and important constituent of the coal, as because it is there for giving a very high energy. 1 mole of carbon is there for giving 97.6 kilocalories of energy, which is in the form of heat. So it is a very important component to give energy. So it can be calculated like this. So by increasing the quality of if we need the good quality coal, there must be the highest amount of carbon present. So higher the amount of carbon, good will be the calorific value and low will be the ignition temperature. In this way, coal is studied in terms of its proximate analysis, and proximate analysis is done. Guys, for the study, it can be asked for 5 to 6 marks, while sometimes the significance of coal is asked differently. That what is the significance of coal may be the different type of question. So with this, we will stop here. And thank you for watching this particular video, and watch it properly, make its notes, and also write it in your paper properly, point wise and according to the weightage of the question. So guys, thank you for staying tuning with me here. If you like this video, like it, share it to your friends, and subscribe the channel if not already, and also hit the bell button if you need such type of videos. Thank you once again.